10.1, circles. So what we have here is just a main circle. What I'd like to know is what part of this you don't recognize, or something about it that is different than what you've seen before. Noah.
Chord.
A chord. Okay, so if we look at a chord, it goes from one point on the circle to another point. All right? It's not a line, it is a segment. Anything else? Secant. Secant. A secant is like a chord, except it is a line. It goes through the circle. So that is the difference between a secant and a chord. And then tangent, I assume, is another one. Tangent only hits at one point and is perpendicular to the radius, or the diameter in this case, meaning it's 90 degrees. This is called the point of tangency, where it touches the circle. All right, so this is all vocabulary we need to make sure we understand as we progress. All right, and I assume everybody knows radius and diameter. Everybody remember that the diameter is twice the radius. It takes 2 radii to make a diameter. All right, let's move on. Let's go to the next slide. Okay, here are all the names again of what we just talked about. Look down at halfway down here. Coplanar circles and common tangents. Okay, so let's talk about this for a minute. This piece right here. You can't see it? No. Oh, well, why not?
Yeah, it's like super dark on one side.
Wonderful technology. I'm so glad. Why is it lighter there? That's weird. Okay. So 2 points of intersection when you got 2 circles that intersect each other, okay? You also can have 1 point of intersection where you have a circle on the inside, a circle on the outside, where they touch at 1 point. Now, this would be a tangent line. And this is a tangent line. This one is called external. And this one's called internal. Make sense? Internal means it goes in between 2 circles. All right, and then the last one here, no points of intersection, meaning the circles don't touch at all, or one circle's inside another circle. These are called concentric circles. Concentric means they share the same center point. So if you need to write that down, write it down. They share the same center point. So let's take a look at the extra stuff. Make sure we can see this. Now, everybody, go ahead and write down what the name of 2 radii are. Let me actually start this with you, okay? We're going to name 2 radii here. Well, AD is one, and here's how you would write it. That segment. AF is another one. And again, you can change the order of your letters if you want. You could have said DA and FA. Is there another one? AB. Okay. Those are radii. Now let's go to a chord. Okay? So name a chord. Go ahead and write it down. What you think it might be. If you said DF, that's a diameter. Yes, by definition, DF is also a chord. A diameter is also a chord, but it's proper to call it a diameter. So we would say DE is, the segment DE is a chord. The segment CE is a chord. And again, you can change the order of your letters. Any other chords? Now, yes? Radius, yep. Okay, so let's go down to number 4. Skip number 3. A secant would be written like this. DE, and then you need the line symbol above And that's how you know the difference between a chord DE and a secant DE. Just by looking at those symbols. All right, now, the diameter we already said, that's DF. Now, you guys, on your own, write down the name of a tangent. Okay, you're having problems because they should have given you more than one letter. So you can say line B. Line B is your tangent line. It should have given you another letter on there so you could have just said what it was. But then the point of tangency would be point B. Are you okay with all that? Yes.
For the number 5 for a tangent, if there was like another variable, would we put the line symbol above it? Or?
Let's say BG. You would say, yeah, you put the line symbol above it for a tangent. Okay. I mean, a segment can be tangent as well. So if they only give you a segment, then only use a segment line. Okay. All right. So now let's go down to number 7. How many common tangents are there? All right. So this is how you do this. You draw a tangent on one circle that would be a tangent on another circle. That is one common tangent right there. They share the same tangent, even though the point of tangency is in 2 different spots. Okay, so if you can draw a straight line and it's tangent to 5 circles, then that's a common tangent between all 5 circles. Okay, can we draw another line of tangency? Yeah, at the bottom. That would be a line of tangency right there. And 2 different points of tangency. Excellent. Now, are those internal, external, or one of each, or neither? First of all, if it is a tangent, then it's either internal or external. So what are they? They're both external because they do not go between the circles. All right, excellent. So external are what those are. Number 9, try to make it a little more light here. I don't understand why it did that. Number 9, find BD. All right, so now we start doing our algebra stuff. So BD is this line right here, this segment. So let's call it X. How would you go about solving this? Yes?
Would you do the Pythagorean theorem?
Pythagorean Theorem. So let's talk about the Pythagorean Theorem since you guys did so well on that in Chapter 9 test. Too many of you missed this. We did this in Section 1 of Chapter 9, and we used it throughout the whole chapter, and yet we still didn't do very well. So let me point out what you need to do. So since D is the point of tangency, we know this is 90 degrees, and therefore this is a right triangle. And therefore we can use the Pythagorean theorem. The issue is you need to understand these are your legs. Those are your A and B in A squared plus B squared equals C squared. And that 10 is your C, your hypotenuse. So many of you couldn't even set this up properly. So here's how we need to really do this. And X, A and B can be interchanged, okay? I could have put 5.5 first and X second. It doesn't matter. Oops, I put that in the wrong spot. Up, down here. X squared plus 5.5 squared equals 10 squared. Not a lot of room in your book, but let's go ahead and figure this out. You got your calculators? If you don't have one, go get it. Quickly, please. Okay, so let's see what you got.
30.
Very good, 30.25.
I nearly did this because I got your calculator.
And 10 squared is? 100. Tiffany, what do we do to get X by itself? Look at subtract. Okay? So it's attached by addition, so we do subtraction. That's okay. It's not fun when the teacher puts you on the spot, is it? Right, Romy? What do you get?
69.75.
Thank you, Romy.
Oh, I didn't know if you were actually asking.
69.75. And then again, I want to go back up here to the plus 30.25. Many of you originally on the test would have written this as 5.5 squared plus 10 squared equals x squared, because you put them in the wrong place. But we already discussed why they're A and B. And then if we get to this point, and many of you stopped, you got to take the square root to get rid of the square.
Yeah.
So what is that? 3, 5?
Yeah.
Okay. So that's x, 8.35. Now, number 10. The point C is a point of tangency, meaning if you draw from the center to point C, you get a right angle. If BC, this segment here, is 4x plus 6, find the value of x. All right? So let me see if I can get a different color here. This triangle and that triangle, believe it or not, are congruent. Do you know why? Do they look congruent? They probably don't, because they put this stupid line around the 10, which makes that top triangle look smaller. But it really is the exact same size. And you say, well, AB is congruent to itself by the reflexive property. The radius is congruent, and this radius is congruent to the other radius, 5.5. So I have side-side angle. Except you're not allowed to use that, right? And so you have to go way back and you say, wait a minute, this is a right triangle. I have the hypotenuse and the leg. Hypotenuse-leg theorem says that these two triangles are congruent to each other. Therefore, 4x plus 6 must be equal to 8.35. Solve, please. Don't look at what I'm doing. You do it yourself. And then see if you did it right. Should have used a different letter. We'll call this A. What'd you get? Lucas? 0.585, I think is what it is, but it says to the nearest tenth, so that should be 0.6. So x up here is 0.6, and this was 8.35. Should use different letters. Okay, now you've seen how to do this. Now I'm going to spend the next 20 minutes helping you with your homework on here. So everybody get their books and open them up to page 534. We're going to do 5 to 32 all. We're going to see how many we can get done.